So our learning goal states, I can identify and multiply special products. Now I am going to make like a disclaimer. That is, this is a method that, first of all, can only be used for these special products. But if you're like, you know what, this just confuses me, I can't handle it, I keep getting them wrong because this doesn't make sense to me, then use one of the other multiplications. Because this is going to be a binomial times a binomial. So you're going to be able to use FOIL if that works better for you. You're going to be able to use the rectangle method if that works better for you. But these are going to be some shortcuts that, in reality, it'd be a good idea if you could learn really how to use them because they're kind of handy. So first thing I want us to do is I want you to put a box around when a binomial is squared. So in other words, it's a binomial times itself. And in our A and plus B and all this going on down here, this is exactly what they're talking about. When you have a trinomial or a binomial, times itself, and in this case, we're talking about with addition between the two terms, we can say that it is called a perfect square trinomial. The result you get, the product you get, should be what we call a perfect square trinomial. It's a special product. When we have addition between the first and second term of that binomial, here is how our perfect square trinomial will end up. We're not going to FOIL it. We're not going to do 4 multiplications. We're actually going to do 3 because a trinomial has 3 terms. We can just do 3 multiplications. So A, if we want to write this, this might be helpful. A is really referring to the first term of binomial. That's really what the A is meaning. And the B is the other term, second term, whatever you want to call it, of the binomial. So when they're talking abstractly A and B, they're saying the first term we'll call your A, the other term we'll call your B. When you have addition going on between them, here's the shortcut you can take. You can square the A, add to that the product of 2 times A times B. In other words, you're going to multiply 2AB, because if you look at your work in those 3 notebook problems you did, do we have any of this type in those 3 problems where we had addition in the binomial and it was a binomial times itself? Do we have any of those? Which one? The first one. 2x plus 3 times 2x plus 3. That's a binomial times itself, is it not? Has addition going on. So basically, look at the work for that one. What happened with 2 of your multiplications? What were the results that you could say about? Well, let's talk about FOIL. What were the O and the I steps? But what did we get? What did you get for the outer and the inner in this one? 6x. Both times, right? You got 6x and another 6x. So it's kind of like saying you got 6x twice. So this doubling AB is really saying you're going to get the same thing twice. So just take them times each other. Take the x times the 6, the first term times the last term, and 2x times the 3 and get 6x, and then double it because you should end up with 12x in your answer. So that's add the product of 2AB, and then last but not least, square B, and you will have your answer. So let's see if that would work in this one. 2x times 2x, squaring A. What's 2x squared? 4x squared. Here it is. We just said 2 times A times B. 2x times 3 is 6x. 6x doubled is 12x. Take the 3 and square it, you get 9. So we can just do kind of like a quick 3 multiplications instead of having to do the whole process of FOIL. But then there's also another perfect square trinomial. What happens when you have subtraction going on? So in other words, if there's subtraction going on between the first and the second term, it's still a binomial times itself, like our number 2. X minus 7 times itself. It's a binomial times itself, but this time it has subtraction. So notice what's different. This time we're going to still square the a. We're still going to take the product of 2 and a and b, but notice what we're going to do. We're going to subtract it this time. Because what happened when you did the O and the I step in number 2 of your practice? What happened to the O? What is the O and the I step? What'd you get in number 2 here? What'd you get for O step? Alexis? Negative 7x. What'd you get for the I step? Negative 7x. What happens when you add negatives? Stay negative. You get a negative. So we ended up with negative 14x, didn't we? But yet so that's why you have to subtract the product of 2a and b, and then we're going to add squaring b. So again, 7 times 7 is 49. Now, you're gonna feel a little bit like, well, wait a minute, we have to count that 7 as negative. Not in this shortcut, we don't, okay? So let's just go do some practicing. I think it'll make more sense. Number 1 through 3. First thing we're gonna do is state whether the product would result in a perfect square trinomial. So in other words, you're gonna make a decision. Could I even apply this shortcut model rule to it? So first thing you gotta see is you gotta say, is it a binomial times itself? Yes. So we would say this is a perfect square trinomial. This would have a perfect square trinomial answer because we can write it as a binomial times itself, or a binomial squared. So I can apply this shortcut. I could do the a squared. This one has additions, so I could do plus 2ab plus b squared. I could apply that model to it. Or I could just FOIL it if I can't figure it out that way. How about this one? Would that be a perfect square trinomial type? No, because we can't write it as a binomial squared, can we? One has addition, the other has subtraction. They do both start with x, and they do both end with 2. But one's got addition, the other's got subtraction. So on the back side, we'll learn what that kind is. And then, how about this one? Could this one be, would this be a perfect square trinomial? Yes, because again, we could write it as 5x subtract 6 squared. So all we're doing here is we're just recognizing when could we use the model, the shortcut for a binomial times itself. I first have to recognize that that's what's going on. And then, now we're going to do some practicing. So we have a binomial times itself here. So the first thing we're going to do is identify what's our a value and what's our b value. Because our model, remember, goes a squared, this one's got addition, so plus 2ab plus b squared. So what is our a? X. What is our b? 7. So we're going to square our a. I always do that. I write a instead of what the a is. A is x, so we're going to square x. This has addition, so it's going to be plus plus. This is the one that has the model a squared plus 2ab plus b squared. So now we're going to put 2 times our a value times our b value. And then we're going to square our b value. So our first term of our perfect square trinomial is x squared. Our second term is 14x. Our third term is 49. If we FOILed it, we'd get the same answer. If we used the rectangle method, we'd get the same answer. Okay, let's look at number 5. What's our a value? X. What's our b value? Okay, that's the part that's tricky about this. You don't have to worry about the subtraction sign in this shortcut model. You just say what's in that last spot, and you get to leave it as subtraction. So you just say it's 1. Okay, Yes, get a little confusing. If we're going to use the shortcut model, we get to just treat that as a positive 1. Here's where we deal with the fact that it's got the subtraction in it. Because it has subtraction here, we know we're going to have subtraction between the first 2 terms and addition in the last. Because when you add 2 negatives, you get a negative. When you multiply 2 negatives, you get a positive. So this one's going to be the a squared minus 2ab plus b squared mod. So we're going to square our x. We're going to take 2 times x times 1. And we're going to square our b. We're going to have x squared, subtract 2x, right? 2 times x times 1 is 2x, plus 1. There's our answer. Okay, you go try number 6 on your own. Let's see how. So fill in the a, fill in the b, decide if it's going to be the plus 1 or the minus 1. What's our a? 2x. What's our b? 10. Okay. Is this a plus 1 or a minus plus? Plus because there's not subtraction, there's addition. So now we're going to square 2x. Those parentheses that time are not optional. You have to use them. We have to show that 2x is getting squared. If you don't put the parentheses there, you write it like this. 2x squared. Is the 2 being squared? No. You can't write it like that. You have to put it in parentheses when it's more than just like a variable or a number alone. And then we have our 2x here, our 10, and in here we have a 10 that's getting squared, right? Okay, what's the final answer for this one? Connor, got it for me?
4x. 4x plus 4.
Want me to change something?
And you just have those together.
Well, they are like terms right now, so we probably could. But do you want to finish and then we'll see what was your next thing?
Plus 1.
Plus 100? Is that what I heard? Okay. So now you're saying I could add these 2 together? But I'm here to tell you that if this is a perfect square trinomial type, then we got to have a trinomial answer. So, but yet we could add those together right now, and then it would become a binomial. So something must be wrong. Mitchell?
It should be 4x squared.
Why?
Because of the 2x squared.
Because 2x times 2x is 2 times 2 is, and x times x is. Yeah, so we need this to be squared, don't we? Okay. Okay, now, let me show you what kind of work you need to show, because it's not going to be, your worksheet's not going to be set up like that. Here's how your worksheet's going to look. I have x minus 8 squared. I first asked myself, would this be a perfect square trinomial? Would my answer end up a perfect square trinomial? Because? Well, it's not just because it's subtracting, but also same binomial times itself, right? So we don't even have to write this out as x minus 8 times x minus 8. We can go right to this. We can say, oh, this is going to have this is one of my special products. It's going to be a perfect square trinomial. So I can identify my a, I can identify my b, and then I got to decide, after I do that, I got to decide which model I should use. Should I use the a squared plus 2ab plus b squared? Or should I use the a squared minus 2ab plus b squared? The second one, because it's subtraction, isn't it? So What's our A value first of all? X. What's our B value? 8. This, you're going to show me this much in your homework. You're going to show me, what did you identify A and B as? Because then you're going to square that A. Because it's subtraction up here, there's going to be subtraction here in front of our 2. And then we're going to add our B value squared. So you go ahead and substitute into that because you already know how to do that. So I'm showing you right now the minimum amount of work you can show. Anything A, B, substituting in, and what's the final answer? What you got, Zach?
X is second power minus 60x plus 60.
64. You guys agree with him? That one looks a whole lot like number 2, except it was x minus 7, wasn't it? We ended up with x squared. X times 7 is 7x. Double it, 14x, it gets subtracted. Take 7 times itself, get 49. So, Zach is right. Okay, number 8. A binomial times itself. A equals, B equals. Will this be a plus plus or a minus plus? This will be a plus plus. So the A value gets squared. We double the A times the B. We square the B. And our final answer for this one is, Landon?
X squared plus 4x plus 4.
You guys agree with him? Yeah, thumbs up, you got it? Say this is okay? Again, if we FOIL it, we get the same thing. It's just that, you know, it seems like a little bit less work, doesn't it? FOILing? Okay, you try that number 9, totally on your own. I'm not gonna keep my mouth shut. We still don't like they have the answer. They got it. Willing to share it. Oh, yeah, remember what do you got?
49x squared minus 70x plus 25.
Anybody else get that answer? I don't agree with you. So what's A? 7x. What's B? 5. So, are those parentheses important around that 7x? Uh-huh. Okay. How about this question mark here? What should I change it to? Subtraction. Why subtraction? Because why?
7x minus 5.
Yeah, because of that minus right there, right? It's a subtraction one. Okay, so now I put my 7x in here, and I put my 5 in here, and I put my 5 in here. What should that question mark be? This one's always gonna be plus, that's a little, alright? Always, you don't even have to think about that one. It's always, the last one's always gonna be plus the last term. So is 7x times itself 49x squared? Sure is. How about 2 times 7x times 5? What's 2 times 5? 2 times 5? 10. And 10 times 7? Yeah, remember, it doesn't matter what order you multiply in. So 70 minus 70x, don't forget about that. And 5 squared, 25? Yeah. Okay, I guess we're going to stick with that answer, aren't we? Okay, questions on this? Because you know what? We had a couple of those in our practice, but then there was this one. Look at this one right here, 4x plus 2 times 4x minus 2. Would that fit this category? No, they both start with the same thing, they both end with the same thing, but one's got addition, the other's got subtraction. That's a problem. So let's go to the back and see what we can do with those, because those are, I love these. When you multiply certain types of binomials, the middle term will be 0. In other words, in FOIL, the O and the I cancel each other out. In the diagonal of a rectangle method, they cancel each other out. And so you end up with just 2 terms in your answer. You end up with a binomial answer instead of a trinomial answer. Well, that's going to happen when you have a binomial times a binomial. They both start with the same thing. They both end with the same thing. One of them has addition. It doesn't matter which one. The other one has subtraction. When that happens, here's what you should get. A squared minus b squared. We don't have to go through all that foiling because these 2 steps are going to cancel each other out. So I'll leave that for you guys to study, but I want you also to, this is really important, this is called a difference of squares. So not a perfect square trinomial, but our answer this time will be called a difference of squares. Difference meaning subtraction, squares meaning you have something that you can take the square root of. Okay? So I'll leave those examples for you to study, but we'll move on to being able to identify. So now this is kind of like on the front. There was one that wasn't a perfect square trinomial. I bet it was a difference of 2 squares. Let's look at number 10. Is that a perfect, would that have a perfect square trinomial product? Why not? One's addition, the other one's subtraction. Oh, they do both start with an X and they do both end with a 10, but oh, they don't both have the same sign in them. So that means it's what kind then? Difference of squares. Yeah, we're going to call this a difference of squares. Because we have to know, first of all, what type we're dealing with so we know which model to apply. Because this model is different than the other one. This one is a squared minus b squared. How about number 11? Which model will we use for that one? Alexis? Yeah, this one's a perfect square trinomial. This one's a perfect square trinomial because it could be written like this. Y plus 6 times itself squared. So this one we could not use the a squared minus b squared. Anybody know which model we would use for that one? What would the model be for this one? Yeah, a squared plus 2ab plus b squared. Okay, how about this one? Is that a difference of squares? Or would that give us a perfect square trinomial? Yeah, because this one can be written as a binomial times itself. So this one too would be a perfect square trinomial after we got done multiplying it out. What model would we use for that? Because if it's a perfect square trinomial, you can't use a squared minus b squared. Same one as it just said. A squared plus 2ab plus b squared? Yeah. A squared minus 2ab plus b squared. Remember the minus plus? Okay. Okay, let's go practice. What happens when they are the difference of 2 squares? Okay. So we have this a plus 7, a minus 7. They both start with a. They both end with 7. One's got addition. The other's got subtraction. So that means it's the difference of squares. What's our a value? A. This time it is a. What's our b value? 7. So all we have to do is square A. All we have to do is square 7. And presto, we're going to have our answer just like that. A squared minus B squared. That was a whole lot less work than boiling, wasn't it? Okay, how about number 14? Would that be the difference of two squares? Difference of squares? Yes. They both start with 2. They both end with 3m. One's got addition, the other's got subtraction. So what's our A value? 2. What's our B value? 3m. So we square our A. We square our 3m. Parentheses are not optional here. They can be on the 2 squared, but they're not optional on the 3m. Getting squared. We have to start with our A squared, because it goes A squared minus B squared, so 2 squared is 4. Minus 3 times 3 is 9, and m times m is m squared. Now, we're used to that the answer is usually in standard form. We can't just have these straight places, though, can we, to be in standard form? This has to be written how in standard form? Or, what would standard form be for that? Negative 9m squared, what? Plus 4. So if we want to turn it around and put it in standard form for an answer bank, that's how we would rename it. Okay, minimum work to show for these. Here it is. A equals, B equals. What's going to get squared? Subtract from that what else is going to get squared, and then what's my final answer? Okay, what's our A? X. B is 8. X will get squared. 8 will get squared. Our final answer is? There we go. We got it. So painless. And our last one. A equals, B equals. A is 10. B is 2x. 10 squared, take away 2x squared. So that's 100. Is that what I heard? Take away what? 4x squared. Or, if this one is, what would this look like in standard form?
Negative 4x
Plus 100, yeah. Okay. Whew. Takes longer to go through the notes for this than it'll take you to do the homework. Okay, the homework is a worksheet, and you may do your work right on the worksheet, or you may show it on loose leaf. That's your call.